Section 5.6, naming acids. Acids are easy to recognize because they start with hydrogen. So if it starts with hydrogen, it's an acid. Bang, done. We can think of acids as being a molecule that has hydrogen ions attached to an anion. Acids are not ionic compounds, but when you dissolve them in water, they do ionize and form ions. So we can kind of think of them as ionic even though they aren't. So they're going to have an H plus ion and then an anion attached to it. So what we have to do is look at the anion. If it does not have oxygen in it, then we use the prefix hydro, and then we take the element's name, we change the ending to ic, and add the word acid. So examples are good. So HCl. We see the H, we say this is an acid. We look at it, there's no oxygen in it. So we take the name of the anion, which is chlorine, and we change its ending to ic. We put the prefix hydrochloric and a space acid. So acids also have two names, but they always have the same last name. And so from their name, they're very easy to recognize as well. They all end in the word acid. HCN. So we see the first letter, H. This is an acid. We look for oxygen. There's no oxygen. So we name it using this hydro blank ic acid. Well, what is CN? That's not a single element, is it? That's one of those polyatomic anions. So we're looking at the name of the anion. That is cyanide. So we change the ending of cyanide to ic, and we get hydrocyanic acid.
Is it really a carbon and nitrogen together that makes that, or is it just totally different?
No, it's carbon and nitrogen. And they're triple bonded to each other, and it's named cyanide. I don't know why.
We just accept that.
We just have to accept that. Yes, there are some things in life that is because it is, just.
Do you get that discussion with the kids?
Pardon me?
Do you get that discussion with the kids?
I do. They all go through this phase where they ask why, and eventually you get down to because.
Or you say, why not?
Why not? Yeah.
Just to mess them up.
Just to mess with them.
Okay, so we're looking for the H, and then we look to see if it has an oxygen.
Right. You look for the H, that says it's an acid. If it does not have oxygen in it, then you use this pattern, hydro something ic acid. So here H2S, no oxygen. The S is sulfur, so we change the ending to ic, and we get hydrosulfuric acid.
The numbers don't matter.
The numbers don't matter. Now, why are the numbers what they are? Let's talk about that real quick. Well, what's the charge on a sulfide ion? 2 minus. And when hydrogen is +1. Now, we look at that and we say, oh, well, that's why there's 2 hydrogens. We need 2 hydrogens to balance the -2 charge on the sulfur. Cyanide and chloride both have a -1 charge, and that's why they have 1 hydrogen. Since hydrogen is +1, you can just look at the charge and see how many hydrogens it needs. If it was a 3- charge, it would have 3 hydrogens. So there are actually not that many of these acids that do not contain oxygen. And some books call them binary acids. The only bad thing about calling them binary acids is that hydrocyanic acid is really not a binary acid because there's 3 elements in it. So, pardon me?
I'm just going to forget that part.
Say
Yeah.
that part again.
Well, some books call them binary acids,
Right.
and most of them are 2 elements, but the hydrocyanic acid doesn't fit in that pattern. So I like the way this book says. It. If there's no oxygen, you name it this way. And then we'll save the next part with the oxyacids for Wednesday.